Okay, hey guys. Yeah, so I'm gonna do some slides. Just go through some basic stuff for that you need to know about game dev, and then we're just gonna do some code. Like we're gonna start from a fresh game and then do some coding. Okay, so the first thing I wanted to say is like I've tried before doing games with HTML5, and it's actually not a great idea. Web is not really made for games. That's one thing. If you really want to get to games after, then HTML5 would not be the right solution because you're always restrained to the browser, and it's not the most optimized for games. But there are engines that let you use JavaScript, which is kind of cool. So I recommend one of these three engines if you want to start making games. I'm using Unity, but Unreal Engine is pretty good as well. CryEngine is very new, and I heard a lot of good things about it, but that's all I know for now. So yeah, the first thing you should be doing is like choose your engine and choose one that are the most popular one, or the ones that can make you export your game in different platforms at the same time. So one thing about game development is everything is pretty much object-oriented. It's very heavy in object-oriented, so many hierarchies. Yeah?
What's the purpose of a game engine? Like, what does it do?
So game engine provide the physics, the environment. It's like it sets up everything you need. It's mostly physics engine.
Similar to like a language, like a framework, where you get certain APIs, or like what? Is it an IE?
I think you'll know more when we start making the game, and I'll show you more stuff. But it's basically a physics engine. It puts object in the world in a 3D environment, and then it can give you access to these game objects where you can do whatever you want with them. But I think you'll know more once we start coding. So yeah, I wanted to say it's very heavy and object-oriented, so many hierarchies, and the great object-oriented design will save you so much time, and this is from experience. I've been doing games for just 2 years, by the way, but I've learned a lot in the last 2 years. And like everything goes in your classes, all the logic, and so then you have the engine gives you these controllers, where so the update runs every frame of the game. Fixed update runs every frame along with the physics engine. And you'll see more of this stuff. On trigger is when two things collide, and it gives you the ability to call something from your models. And start, as soon as the game starts, you can call some piece of code in there. So yeah, so the one thing in every game engine, everything is like, it's all game objects, and you're just using code to interact, to make them alive, basically. Okay, so yeah, so we're gonna start just make a game from pretty much scratch. I just have some assets here. You can do nothing at this point. Like, there's no control, there's no scripts, there's nothing. So what we will do is just, first thing we'll do is basic movement. The player gonna move. The second would be make the camera move with them. The third, we're gonna add time mechanics. That means take 3D models and place them in the world the way you want. You create in your scene and place the character, place everything, and everything is a game object. So everything can be moved. So like this is the player, you want to move him, this is how it's moved. But we're going to do that by code. So, and here you can see all the game objects. And every game object has a transform. That's what going to allow you to make it move. So like this, if we change his X position, then he's moving in the world. So that's the use of the game engine. So let's start with the first feature, just basic movement, I guess. Here, the only thing I put in script, or have nothing, we just have these global variables, which is always good to keep everything constant in here. Yeah? Oh, yeah. No, I have to make it bigger. This is better. So this is just some constants I'm gonna need. I set them up so we don't have to look for the exact values. So let's start by making the first class is the night class. Just gonna copy some code from here. I'm gonna call it the night. You can stop me anytime, by the way. So night class, it doesn't have this. So night, and this is C#, by the way. So it's very close to, it's not very close to Ruby, but like this is what I'm gonna do is the constructor, which is the initializer in Ruby. So I'm gonna do night. So the night takes the, has a transform, and transform is actually just this. Because we wanna change his movement in the world, then it takes as, it has a transform that we can then use to change. If you can see here, this is a transform. It's changing the positions of that night. So it takes a transform as, for now it just have a transform as its attribute. So it takes a transform. And this is like Ruby, we're just initializing. This is as if this is the initializer. And you start, you put in the transform. So now we want to make the character move right, back, up, and down, right? So let's look at forward. To make this character move forward, if you look here, the x is decreasing when he goes forward. So that's what we'll do. We'll do a method called move right. That will use the transform and change the x to move by the block. And please stop me if you don't understand something. So it's very simple. So you're going to do transform that position. And you want to move by a vector with the x. So let's say I want to move from here, to this block. I'm moving by the distance, increasing the x or decreasing the x by 0.9 or 1 unit. So that's what the code would do. So it's because it's moving, it's decreasing the x, so minus. And then global. Here I'm going to use the size of the box, which is 0.9. And then we're not moving on the y-axis, and we're not moving on the z-axis. We're only moving on the x-axis by the box size.
Can you translate this method into a Ruby method, just to know what?
Yeah. So new vector is like vector.new vector.
It's a class.
Yeah, and this is the x-axis, the y-axis, and the z-axis. So you're taking a transform as if I transform that position. The transform class has a position, and you look into that position. So as if it's I transform that position and decreasing the x-axis by the box. I don't know if that.
Void just means there's no return, right? Like in C#?
No, this one, there's no return. When you do void,
Yeah.
there's no return. Yeah.
There's no return.
Um,
Static just means that it won't have any instances just by itself.
Actually, that one's it's not static. A static means it's a class. It's one class.
There's one class.
If you do static on here, that means it's a class method, a class attribute. If I do static on here, it's a class method. The way you have it in Ruby self dot, and if you don't do anything, as if it's same as Ruby.
What does void and new mean in C#?
Void means it doesn't store a value. So if you return something, it's not stored. Yeah. So you have to
explicitly declare your variable types in C#. So if you put like ints, you can only return ints, or string, you can only return string.
Yeah.
And why vector 3?
So transforms, you're moving them with a vector. Any?
Is there a difference between vector 2 and vector 1?
The vector 2 is only x and y. Yeah, there's only two types. Vector 3, x, y, and z. Vector 2 is x and y, and you only need vector 2 when you're doing 2D games. We're doing technically a 3D game. So we did the move right. Let's put it in our controller. So we have to have a controller that's gonna call the move right when you press right. So let's do that. I'm gonna make a folder called controllers. Go C#, script, night controller. So that script is we're gonna add it to this night object. That way it controls it. And so basically when the game starts, this is where the controller is. This is where you instantiate stuff in I'm gonna use the wake. As soon as the game starts, we're making a new night instance. So we'll do night equal night.new, and we're passing in the transform. So I'm gonna declare it here. Night. So just as soon as the game starts, we're making one instance, which is because we have one night in the scene, so we're making one instance of night from the class. And then here is where we're gonna take the input from the user. Say when move right, we're gonna call the move right from the class. So if input that get button down right. So that's when we do night that move right. Is this clear so far? So yeah, everything else is in place. So we see it's giving us an error, unexpected new. Oh, I did in the Ruby syntax here. I get confused because I do multiple. So this technique should make it move right. So you see him moving right. He's disappearing in the scene because the camera is not following. So what we'll do is just make the other movements really quickly here. So move left. Move left will be the opposite of this. Move up, we're moving on the z-axis. So instead of the x-axis, we're not moving the x-axis, we're moving on the z-axis. And move down is the same thing but the opposite. So, and then what we do in the controller, we call these one by one really quickly. So left will move left. Down will move down. And up will move up. So unless we missed something, I think this should be it for all the 4 movements. Well, one of them is up. I reversed so the up because the up, if you look, the Z is decreasing when you're going up. So that's why you have a minus here. So now technically we have all 4 movements. Is this image clear? Yeah. So I can move all positions. So the problem here is when the player is going, he's off screen. So we have a camera game object in the game, and you gotta make it move with the player. So we need to have a controller for the camera. So let's add a camera controller now. Not JavaScript. See, by the way, you can use JavaScript in Unity, but I don't know that much. Like I know JavaScript, I never used JavaScript with Unity. So we're gonna do camera controller, and in the camera controller, all we have to do is for every frame, the camera basically moving with the player. If you look, this is the camera in the scene, and I'll make it big. So it just have to move with the player. It's moving on the x-axis. So if you see it, if it's moving from left to right, if you see the x is decreasing. It's basically, we want the x to be the same as the player. That way it's following the player. So let's do that. Here I'm just gonna expose the player instance, so it's available from anywhere. I can do that by doing this. And it's static, because we only have one player, that's why it's static, which is one class method. So player, and in the night controller, we'll say this is the player. So night, that player is this night. We define which player is the night. So in the camera, so what we'll do is we'll define a new vector, which is a new position where the camera should be. And the starting point should be the camera current position. And then what we'll do is we take the x of that position. We're trying to make it match the x of the player position. So new position, x equal night, that player, that transform, that position, that x. So this way, the new position is with the player's position. Finally we're going to set this camera position to that new position. So transform that position equal new position. Hope this is clear as well. So here we're taking the camera position. We're making the x match the player's position. And finally, we set this new position to the camera position.
How does that controller know about the camera? The other one you had to make a new night and kind of associate that with it? Or is this one you never kind of made a controller option?
Oh, it's basically when you grab the camera controller and put it in here under the camera, it accesses the transform, it accesses this. So that way you have access. Yeah, once the camera controller is in here, it has access to this transform, and that's what we're gonna do. We're gonna match it. So let's see, we have an error here. Starting night player. So here I'm gonna show you, but it's missing one thing. So as you see, the movement is not kind of nice. It's very abrupt. So Unity gives us this. What we're gonna do it's like in CSS, there's transition. We're gonna make the camera not exactly snap, but smoothly transition to the new position of the player. So for that there's a method called vector3 lerp, which basically just smooths the current position to the new position. And the last is the speed of the camera, which is global, and I have it here, camera speed. Don't worry about the last one here. I'll explain it later. But basically delta time is Oh yeah, delta time between frames. How many seconds has? If the frame rate is low, the number of seconds between one frame to the next frame, and we need it for the speed. So now the transition should be a little bit better, slightly better. So now we can move into the world and we have movement. Another thing that this game should have, or one of the features of this game, is the player should roll back in time. I don't know if you played the early Prince of Persia where you can roll back in time. So let's do that really quick. I kind of need water. Can I grab water 2 seconds? Is this a lot of information?
Is it like we should like learn like C# or JavaScript for sure? Kind of like, well, is there any like game engine that support Ruby?
Ruby's not a good language for
No.
no, like not at all.
Actually, all these languages are converted to C++. You need to go, but you can do any language there anyway, but you're very limited by the speed. You want pretty much high speeds, a high frame rate in your game. But if you're making very small, easy, like 2D games, then you don't need to. But chances are, if you're into the gaming industry, you will start with easy games, and then eventually you want to do more, and then you have to go with stronger engines. Okay, so let's do the time mechanic. So the player can roll back in time. Do you guys know about stack? Yeah. So just to be able to do a time mechanic, basically every frame we're saving the state of the player in a stack. So like the player is here at x equals 0, x equal 1, he's here. Like every time we're adding his state. For now, for this, we're just doing the position. And then when you roll back in time, you're taken out of the stack and update with that position. So it's very simple. So we're gonna do. Shouldn't do publicly. So we'll define a stack called positions. We're only rolling back positions. So we define that positions equals stack, new stack. And what we'll do is we'll do save. So every frame we want to save the position. Therefore, we're adding to the stack. So we'll do positions that push, and we save the position of the player at that moment. And if we want to revert time, then we do revert. Then we're popping out of the stack. So, but we have to check if the stack is not empty. So if the stack is not empty, we're taken out of the stack, and we're making that the player position that position. So positions that pop is to give us the position on top of the stack, and we're making that the position of the player. So that's pretty much what it is.
Wait, pop doesn't remove the last element of the array?
The pop removes it. So if I'm not reverting time, then I'm saving time. So if I'm saving, I'm pushing it to the stack. And then when I'm reverting, I'm taking it out of the stack and updating my player position with that position. Take it out of the stack. Yeah.
So you move back one step, basically.
Yeah, move back one step. So this, I need to do casting here. But this should be it. So what we'll do, we'll be calling this in our update. The update, by the way, runs every frame. So if the player is not doing anything, if he's not reverting time, then he's saving time. So we'll do if he's not, well, it will do if he's trying to revert time, will be like get button, called space is revert, when you press space bar. So that's when the knight will revert, we'll call revert. And if he's not reverting time, then he's saving time, so it's save. That should be it. It's that. But I'm only saving positions here. It gets more complicated when saving more. So let's say I'm moving around the world. Now I'm rolling back in time. So it's rolling back, whatever I did. So I can do all the stuff, like move around, and now it's reverting everything I did. So just to stack up, it's very simple. But it gets more complicated when you're saving the state of the player as well. Not just his position. Maybe he's talking at the x equals 0, x equal 1, he's talking, then you gotta save the thing he said or something. Or whatever he was doing, which we're not doing here, it's out of scope. Okay, so since we have time, I wanna add, I thought by this time we'll be like close to the end. So maybe we'll add traps. We'll make this go up and down. And then after this one, maybe you guys can give me features, and if we have time, we can do them together. So how to make this one go up and down is if you look at the transform, same thing, we're playing with the transform. Y position, right? And if you think about it, this object has 3 states. Either he's resting, or it's going up, or it's going down. So it goes from the state machine of it. It goes from resting state to going up, to going down, and then rest. And all we have to do is like change his Y position when he's going up, when he's going down, and decrease it, and when he's resting, just waiting X amount of seconds. So let's do that. So we'll do, we're going to call trap, but just keep in mind that, as I said, there's a lot of hierarchies in games. Usually you want to have different type of traps. Then you do trap, class, and then spike and everything. But now, because we're saving time, we'll just do trap, which is only, assuming we'll only have one trap. So I'm going to copy some code from here, delete this. So again, it has a transform, doesn't have this, doesn't have this. It's called trap. Takes a transform. And we can do some refactoring after, because there should be another superclass called unit that everyone that's using transform inherits from that, but I skipped that. Okay, so as we said, we have 3 states. The first, we'll just define our states here. And I don't know if you guys know enumerator, but they're just integers, to be honest. So we have 3 states: rest, up, down, and then we have a state. We'll just make these private. A trap has a state at a given time. So it's starting, this is the constructor, that means it's starting as, we'll say it's starting at rest. It's resting when it starts. So let's make sure it's resting here as well in the world. So let's implement when it's going up. So this transform that it's going up, that means the y-axis, it's increasing in the y-axis, right? So that, and here we're working with local position, but don't worry about it. So we're increasing in the y-axis by vector 3 up multiplied by the speed. And then I think I have spike speed in here somewhere. Yeah. This last part, I would say don't worry about it. I'll try to explain it a lot more. The speed, at least. The speed usually means you don't want it to go you don't want it to snap. So you're kind of smoothing in, and the speed is 0.1. So every frame, it's going just a little by little until it reaches. So we want it to only go up while it's less than the. So when you want to go up, as long as it's not to the maximum. Maximum you can see is 0.247. As long as it's less than 247, then it should be going up. Then if you transform that position, that local position, that y is smaller than, and again I put all my variables in here, max y. As long as it's less than the maximum y, then it's going to be going up. Else, let's say that means it reached the maximum, then it's going to go down. So it's going up, reach the max, go down. When it goes down, the state changes to state that down. And that's about it. So this is our up. Yeah?
So is that not going to snap back down because once it starts to go down, then your if statement would now be less than the global spike max? So is it not going to go back up again? Or
It's going to a different state. So this code will not run anymore. This code, this code is when it's going up. We only call it when the state is up. We want to go up. We call this code. Otherwise, it switches to another state. So let's do the down. Down, we'll say, as long as it's above a certain the start of it, the base.
Do you need global spike speed?
One advice I have is to keep all the constants. Oh, here. This is.
You just have spike speed?
Oh. Yeah, that's right. Yeah, so, okay, cool, good call. So when it's going down, okay, so when it's going down, we're decreasing the y, and when it reaches down, then we should be resting for a bit. Like, you don't want the spikes go up and down constantly. Then you make it rest for a bit. So let's do the rest state method, which will be the last one. Rest, we need a timer for this because you need to count 1 second or 1.5 seconds before it goes up again. So we just need to declare a timer. Timer starts at 0. And so here, the rest, while the timer is less than, let's say, 1.5 seconds, which again I defined it somewhere here. So as long as the time is less than the pause of the spike, which here we define at 1 second, then it should, let's make it 1.5 seconds. So while it's in pause, nothing should happen until the pause is finished. So when the pause is finished, then it should go up again. So the state will be up, and we have to reset the timer to 0. So we have our up, down, and rest methods. So only thing left to do is for every frame, depending on the state, we'll call the appropriate method. So switch state. So if the state is up, then we call the up. If the state is down, then we call the down. If the state is rest, then we call the rest. That should be it. We have to add a break for every switch case. Is that clear so far? So for every state, we're just calling the operate method that does what we need. So the last thing, we need the controller that's going to go in the. So we need the trap controller. So we take that trap controller, we put it in the trap, these two traps. We have to private. No. So we add the controller, trap controller to both of them. So now we have a trap controller. So at the start of the game, we're creating a new instance of trap. So we'll do the same thing, public trap, spike in this case. So at the wake, we're creating a new instance of trap, passing the transform. And every update, we're calling the spike.update. We're calling this method depending on the state of the trap. So I think that's it. Unless I missed something. So, no. What did I miss?
It's not starting off at a state, is it, by default?
Hmm?
Does it start off at a state by default?
It starts as a rest by default.
Are you incrementing the timer?
Oh, yeah. Good call. Yeah, so we need to increment the timer. And delta time is the time that.
Will both spikes work, or?
Both of them, yeah. Because for every controller, creates a new instance of the things, the spike. So you see them? So yeah, every instance of the controller creates the spikes. Here, nothing happens technically, but if you want to go more, it's make him die and all that stuff. And then you can see you can reveal all this time that we were doing stuff. By holding space, we're reverting time. Yeah, I mean, I don't have any, like, you guys, we have like some time, you can ask me questions, or we can add new feature together. So
What is the most complicated level of game you can make with this engine?
the most complicated?
Like how far can you go in detail with this game?
As far as AAA, as far as
Things like Gears of War is built on Unreal Engine.
yeah, Gears of War. Most of them are built on Unreal Engine, but you can go as far as you can.
I think plant size built on CryEngine. These are huge. These are like how developers.
Yeah.
So do like gaming companies like EA or whatever, like construct their own engines?
They might actually.
Yeah, I think EA use their own engines. Yeah. Yeah, Ubisoft, I know they have their own engine for Rayman and stuff. But
Would you be able to actually do the 3D modeling in Unity, or do you have to do that?
no, you do that in other software. So it's usually in Maya. That's the best one. That's the artist working with me. What he uses Maya. By the way, this is not our art. I just took it for the sake of it. Took it from online.
Let's say you wanted to take damage when you landed on a spike. How would you do that? Would that only done like?
So that's the on trigger. So as soon as, do you want to do it or you want to?
Do it.
Yeah, we can do it. So we need the health then. Knight. So knight needs the health. Public float health. So health starts as at 100. Do I have something global about it? I do have it. So you want when the spikes. So in the night controller, we need that on trigger. No, actually, it's best to do it on the spike controller. So the on.
How does collision detection work for this?
Yeah. So let's do that. So every spikes have a trigger. So the on trigger event. First, let's define the method in this in the night. Say how much health you want to take off. Like spike hit, I guess. We'll define it spike hit. And we'll say this dot health. Let's just maybe decrease it by 50 or 30. So every spike hit, we're gonna hit the player. So then we do the trap controller, and that's where the engine gives us on trigger event, and then collider, I think. Call. So we're gonna check if the collider is the night. So what we'll do is collider.game object dot name equal, and this one is called night. It has a tag player, so let's use the tags better. Tag player. If the player is hit by the trigger, then we're gonna do the night dot player dot call this method spike hit on him, and that should take self health. Let's only do debug code, because otherwise you won't see it if we don't have effects or anything. So every time they get hit, we'll see something with the new health of the player. Player is hit by 30, and his health is. This is a lot like the Warcraft exercise, I think. So let's see what his new health is. So what else is this? Night star health. Forget the global. Okay, let's see if we missed anything. So we have the spike hit takes 30 from the health. We should do also that adjustment if health. So what happens usually when the health is lower? It's lower than 0. Then the player the knight dies. So let's quickly add that too.
Why is 0 frame? Why do you have 0 F?
Oh, it means just float. It means 0 float. Yeah. Yeah, not frame. So that starts as false. So we have to tell that he died if that true. Okay, so everything should be in place on trigger. Hopefully I'm remembering this. Is it event? No. Okay, let's try it. So let's see the logs. Nope, nothing's happening. Hold on. Calling game object tag. Yeah, maybe I'm not remembering the oh, yeah, on trigger enter. My bad. So let's try it now. Yeah, you see? In the log it says his health is now, player is hit by 30 and his health is 70. So that's how you detect the hit.
So for the on-trigger, I guess you do it two ways, right? You can do it either on the player or on the object. Why did you choose the object over the player?
Like, you mean here?
Yeah, like so you could, you're choosing the collider versus meet the player, but you can also do it the other way where the collider is the spike. But
Oh yeah, you can do the other way. It's because the usually spikes are the triggers. The player, you wanted him to use the full physics. This is where it gets a little bit, like the player has normal colliders, doesn't have triggers. Triggers usually they ignore the physics, so you can go through them. Like the spikes, for example, they ignore the physics, but the player, you don't want him to ignore the physics, so it belongs a lot more in the spike, because the spikes ignore the physics, and then when it hits the player, it should that's where the player should like get hit, and you see the effect. Yeah, that's when you're doing effects and stuff. But yeah, that's it. Now I have 5 minutes. I'm just gonna finish the slides. I think there's one slide left. So yeah, extra loops, extra tips is when you're doing game dev, avoid loops as much as possible, because loops run every frame. And this is from experience. Then it's sometimes the loop is long, then it drops the frame rate. So what you can do is leverage the updates, because the updates is running every time. So that's what I do all the time. In a game, you're technically in a gigantic loop, so you can leverage the update. You don't want to have a lot of long loop within one update. Keep all game constants in one place, because when you're making adjustment to stuff, like the player health, you want him, for example, to start from something different. Like gaming is a lot of tweaking. And if you have all your variables in one file, it's so easy to tweak the game. And you can even have somebody just tweak it instead of him looking for stuff in your code. I have a typo there. So basically, make a game design tool. Mostly what that means, don't make the game yourself as a programmer, but make tools for designers and game designers to build anything. That's also from experience. If I want the artist that works with me to make like a level, I have to create that stuff for him. So for any game designer to just be able to build levels and do stuff very easily. Yeah, this is the company that we're working on. We're gonna actually now focus on VR. But we made one game. It's in Steam. We're making a few other small games and one. But we're gonna mostly focus on VR now. Yeah, just want to tell you what it is. Tidal Affair called. Yeah, it's called Tidal Affair. Yeah. Maybe I'll show you. Maybe I'll just show you the game itself. But this is the game. Oh yeah, I always use Safari, but I can even show you in Steam. Yeah, we released this last November. What we're working on. Yeah, I deleted. It's pretty. Yeah, well, it's in my Unity anyway, so I'll just open it here. But yeah, it's in Steam. It's going to be out in itch this Friday, and then we're releasing in PlayStation this summer.